Welcome to the Terraform tutorial for beginners at Simplilearn. In the tutorial, you will dive into the world of infrastructure as a code and learn how Terraform can simplify the process of managing cloud infrastructure. So whether you are looking to automate your cloud resources or take your DevOps skills to the next level, this course is going to give you the knowledge and practical experience you need to get started with Terraform. And by the end, you will be able to confidently provision and manage resources on AWS and organize your infrastructure with best practices in the mind. Now, before we move on, here's the agenda of our today's session. We are going to start with an introduction to Terraform and infrastructure as a code. Then we are going to set up the environment. Moving ahead, we are going to discuss the Terraform core concepts. Then we are going to launch our first Terraform project with the help of EC2 instance on AWS. After learning that, we are going to organize and scale with modules. Then we will have a deep discussion on managing state with remote backends. After that, we are going to discuss Terraform with real-world use case and also auto-scalable web server setup. And finally, we are going to conclude our session with best practices and troubleshooting. Now, here's a short quiz to test your knowledge. So guys, which of the following is a correct Terraform workflow? And your options are init, apply, plan, or destroy, or plan, init, apply, destroy, or init, plan, and apply, destroy, or plan, destroy, init, and apply. Now, before we start our session, here's a quick info for you. Simplilearn has got DevOps Engineers Master Program, and you can become DevOps expert with hands-on projects with IBM, AWS, Azure, and also you can master all the stages of the DevOps lifecycle. You can also access blended learning via live online classes with free interactive lab. And you can also get access to official learning content from IBM and earn IBM certificates. So guys, hurry up now and join the course. Now, before we move ahead, I request you that do not forget to hit the subscribe button and click the notification bell icon so that you don't miss out any update from our end. So let's get started. So guys, let us first understand what is infrastructure as a code. Infrastructure as a code is a practice of managing and provisioning computer data centers, servers, networks, and other infrastructure components using machine-readable configuration files instead of physical hardware setup or manual process. This means that infrastructure management becomes automated, version-controlled, and repeatable. With IAC, you define your infrastructure in code using configuration files. These files can be versioned, stored, and shared in a very similar way like how you would with the software development. So IAC tools like Terraform enables you to define and provision and also manage your infrastructure in the same way you would manage application code. Now let us try to understand what exactly is Terraform. So guys, I'm at the official documentation of Terraform right now. And if I tell you what exactly Terraform is, so Terraform is an open source IAC tool created by HashiCorp, which is organization. And it is basically used for automating the deployment and management of the infrastructure. Also guys, Terraform uses a declarative configuration language, which means you describe desired state of your infrastructure. Let's say, for example, I would say I want 3 virtual machines running on AWS. And then let Terraform figure out how to achieve that state. Also guys, if I had to tell you, Terraform has a lot of amazing things to actually give. First of all, it has a multi-cloud support, meaning it can manage infrastructure across multiple cloud providers, for example, AWS, Azure, or GCP. Then also guys, it has a declarative language, means you define the infrastructure how it should look like, not how it should be created, which allows Terraform to figure out the best way to achieve the desired state. Terraform also keeps a track of the infrastructure it manages, which helps in making incremental changes and preventing configuration drift. And before making any changes, Terraform also generates an execution plan to show you exactly what actions will be taken. For example, like what resource you should create, not how it should be created, allowing Terraform to figure out the best way to achieve the desired state. Terraform also keeps a track of the infrastructure it manages, which helps in making the incremental changes. And also, let's say, if you are trying to make any changes in the Terraform, it also generates an execution plan to show you exactly what actions will be taken. For example, how the resource will be created, modified, or destroyed. If I tell you one of the use cases of Terraform, it could be cloud infrastructure automation. So guys, what is going to happen is that it is automatically going to provision, configure and manage cloud resources such as virtual machines, networks and storage. And it also manages infrastructure across multiple cloud providers. For example, like AWS and Azure using single Terraform configuration. If I also tell you, you could also scale your infrastructure. You could add or remove resources automatically based on the defined parameters. For example, scaling an application when traffic spikes. You also have this amazing feature of disaster recovery and infrastructure replication. You can set up and maintain identical environments in different regions for redundancy and failover. Now you'll be wondering why Terraform over other IAC tools available in the market. So guys, if I have to tell you, there are a couple of amazing advantages. First of all, I would like to tell you that it has multi-cloud capability. Unlike other IAC tools, for example, like AWS CloudFormation or Azure Resource Manager, Terraform allows you to define and manage infrastructure across multiple providers. Whether you are using AWS, Azure, Google Cloud, or even on-premises infrastructure, Terraform provides a unified approach. For example, guys, in large-scale enterprises using both AWS and Azure for different purposes, Terraform allows them to manage both environments using single tool and configuration. Also, guys, it's open source and community driven. Terraform is an open source project and has such like vibrant community of contributors that regularly develop new plugins, extension, and integration. And this community driven development is kind of very much helpful to keep this tool alive. And also, it ensures that the tool is constantly upgraded and expanded. For example, guys, a large organization may require integration with niche or custom infrastructure providers. And the Terraform community is likely to have a provider or the ability to develop one. And that helps kind of very much. For example, any issues come up or if you are stuck with any error, so the community helps you to debug that. Next, it has an immutable infrastructure. Terraform promotes an immutable infrastructure, meaning that the infrastructure is replaced rather than modified. So, when you make changes to the configuration, Terraform will destroy the old resource and create the new one. And this prevents configuration drift and ensures consistency across your environment. For example, guys, when you are updating infrastructure, Terraform ensures no broken or misconfigured resources are left behind, unlike manual processes or traditional configuration management tools. Terraform also has the ability to generate an execution plan before making any changes, which ensures that you can review what changes will be made to your infrastructure. And this prevents accidental changes or unintentional destruction of resources. Terraform state management also ensures that your infrastructure remains consistent with your configuration files and even when the changes are made over time. For example, guys, a team member might modify a resource directly in the cloud console, but Terraform will reconcile these changes with the stored state and when running the plan also, by ensuring that everything matches the desired configuration. So guys, let us discuss real-world benefits of learning Terraform. The first benefits is improved efficiency and speed. With Terraform, provisioning and managing infrastructure is automated, which actually eliminates the need for manual setups. By writing code for infrastructure deployment, Terraform helps speed up the process, reduces human error. For example, a startup looking to rapidly scale, Terraform allows a team to quickly create and destroy the infrastructure on demand. And you could do in different regions without waiting for the manual intervention. Terraform's plan and apply commands make scaling simple. Next up we have is enhanced collaboration. By using Terraform, developers and operations team can collaborate on infrastructure in the same way they collaborate on software code. Infrastructure as a code enables version-controlled and traceable infrastructure changes, making it easier to roll back changes and track the history of modifications. For example, guys, a tech startup might use Terraform to allow different engineers to work on cloud resources with each person responsible for a particular module. Version control ensures that everyone is working with least infrastructure setup. Next up we talk about is consistency and reproducibility. Since Terraform uses configuration files, the same infrastructure setup can be recreated as many times as necessary, ensuring consistency across environments. This is particularly valuable in disaster recovery scenarios or for creating staging, production, and test environment that needs to be identical. For example, guys, a software company that uses Terraform can set up identical test, staging, and production environments with simple Terraform apply command, ensuring that configuration are same across all stages of the development cycle. Next, guys, you can also do the cost optimization. Terraform makes it easy to define, manage, and deallocate the resources, reducing wastage and allowing better cost management. You can spin the resources as needed and destroy them when they are no longer required. If I have to give you a use case, for example, a data analytics company using AWS might use Terraform to automatically create and delete computing resources for analysis, ensuring that resources are only used when needed. And this cuts down the unnecessary cost. For example, guys, a global e-commerce platform might need to manage a highly dynamic infrastructure with many cloud resources across multiple regions. And they want to automate the provisioning and scaling to meet growing user traffic during sales event. So for this, they can use Terraform to manage their multi-cloud infrastructure and integrate with CI/CD pipelines. By creating reusable modules for resources like virtual machines, load balancers, and databases, the e-commerce platform can be able to provision and scale resources automatically during traffic spikes, ensure consistent configurations across all regions, implement version controlled infrastructure to track changes, and quickly revert to any issues. And the result of that would be faster deployment of infrastructure from days to minutes. There will be reduced human error and operational overhead. And also, guys, you're going to get improved cost management by efficiently scaling up the resources, which you can do it up and down on demand. So finally, guys, after understanding all of these things, you would be actually getting a clear idea that Terraform is actually a very powerful tool for automating cloud infrastructure management and ensuring consistency and allowing for faster and more efficient operation. By learning Terraform, you can improve your infrastructure deployment workflow, reduce manual errors, and become more agile in cloud operation. So guys, whether you are managing a multi-cloud environment or automating complex infrastructure provisioning or optimizing cost, Terraform is an essential tool in the modern DevOps toolkit. Now, with that being said, let us move to the next part where we are going to set up our Terraform. So guys, what you can do all over here, go to Terraform installation. So just type this and you can see all over here, you're going to get this website, which is HashiCorp Developer. And it says install Terraform. So guys, you can actually install Terraform on Windows, Mac OS or Linux. Also, I would suggest you that for installing the Terraform, what you can do, you can see, go to this given website all over here, which is the official website made by HashiCorp. And you can see there's a Terraform thing is there. And if you click on install, you are going to get this respective page. So if you could see, you could install it in multiple ways. Let's say if you are on Mac OS, you can use Homebrew. So actually Homebrew is a free open source package management tool for Mac OS only. And then you have to type brew install HashiCorp tab Terraform. For Windows, I would suggest you need to have Chocolatey. And if you don't have Chocolatey, then you need to install Chocolatey. So just go all over here and just type install Chocolatey on Windows. And you can see the first website that you have that is called as installing the respective Chocolatey. And you can choose it as an individual, but make sure that in your PowerShell, you are in your admin mode and just run this following command. And then you can install the license edition. So this is kind of a very basic process and you can just refer to the official documentation also. So after doing this, guys, after installing the Chocolatey, what next you can do, guys, is that if you download Node.js, so Chocolatey comes along with Node.js only. So just click all over here and go to the official website of Node.js and download it for the window. So just click all over here and you can choose the LTS version and you can download this. Now that's one part of it. Now what you need to do all over here is, since I've already downloaded, I would show you. So just open your CMD. So in the terminal mode, okay. And after opening this, what you need to do is just run this respective command, choco install Terraform. Now after you have installed Terraform, check the Terraform version. So as I have already installed that, guys. So just type this and you can see I have version 1.14.3. Pretty interesting, guys. Now I will also show you the VS Code extension. Now if you don't have the VS Code with you, just go to the VS Code all over here. So this will be your editor. So here you can configure your respective folder structures all over here. So just go all over here and click on this and click all over here, download for Windows, and you'll have a perfectly working VS Code. Now if I have to open VS Code, I will just click all over here and let's say I open my respective VS Code. So it might take some time. Okay. Now go to your extensions all over here. Just click and here you can search Terraform. So guys, you can see there are a couple of extensions. So first install Terraform all over here. So this is a semantic highlighting. And then from this is also semantic highlighting. You don't have to do this. Then this is the Terraform extension. You can have it. Then if you want autocomplete for AWS, you can also install Terraform all over here, which is going to autocomplete your code. Now, this is also the advanced syntax highlighting. Then this is kind of similar to Terraform Completer. And just click on and install. So these two are kind of important extension that you can have in your VS Code. Now guys, I'll also show you, since you'll be working mostly on AWS, so I would suggest you having a AWS CLI also. Let us install the AWS CLI. So what you can do, just click all over here and just click on AWS CLI install. And this will be the official documentation of installing it. And you can see this is docs aws.amazon.com CLI latest user guide getting started install.html. Now there are three different operating systems. First we have Linux, second we have macOS, third we have Windows. Now since I'm using Windows, so I'm just gonna install this. So this you need to download it. So just click on this and you can see the installation will begin and just install it. It's a very easy installation step. Just you need to right click all to the respective steps. So after doing this, your AWS CLI will install. Now you can check your respective CLI version. So I'll just copy this. Okay. In order to confirm that your CLI has been installed, go to your terminal and type AWS version. And you can see you are going to get respective AWS CLI 2.33.4, Python 3.1311. This is Windows 11 and this is exe-AMD64. This kind of output you are going to see. Now it's very important for us where we can actually interact with our given AWS. We can set our regions, we could set our key pairs, the respective thing, and also we could write the configuration with respect to the Terraform and coordinate all from here. So AWS CLI is very much important. Everyone should have that. Now guys, let us move to the next part where we are going to explore the core concepts of Terraform. Now guys, let us try to take a look at Terraform configuration language, which is very much important. So what does HCL stands for? HCL stands for HashiCorp Configuration Language, which is kind of code language Terraform uses to define infrastructure as a code. Its declarative nature allows you to specify like what's the desired infrastructure rather than the how the implementation detail. For example, guys, I will show you these respective configurations. So guys, you can see all over here that we have resource, which is AWS VPC. And in the main, you have the CIDR block. And also, let's say you have declared your respective block type, block label, and you have the identifier and the expression. So you can see the blocks are like the container for other content, and it's basically representing the configuration of some kind of object like resource or something like this. So guys, when you see these kind of configuration, we call it as HCL, which is HashiCorp configuration language. You can configure a very important thing, like you can configure region, you can configure the CIDR block, you can configure your availability zones. So this is kind of very much important, and in this format we basically do it. Now let us discuss a scenario. Let's say there is a large e-commerce company that wants to manage their AWS infrastructure across multiple environments. And let's say the environments are dev, staging, and production. Now, so guys, in this HCL can define, repeat. So in this HCL can define all the AWS resources such as EC2 instances, S3 buckets, RDS databases, and IAM roles. Each environment, dev, staging, and production is defined in separate Terraform files, which can ensure consistency. For example, the AWS S3 bucket configuration could ensure each environment has its own isolated bucket for storing logs, backups, and other assets, following the security's best practices. Now guys, let us try to understand providers. So guys, providers are the plugin that allow Terraform to interact with different cloud services, APIs, and other platforms. For instance, AWS, Azure, and Google Cloud all are providers in Terraform. And if I talk about resources, guys, resources are the components, like for example, EC2 instances, databases, etc., which is managed by Terraform. Each resource is defined by a resource block in HCL. For example, guys, let me show you. Let's say here you have given the provider AWS, and here you have given the region North 1. Then here, let's say you have given your given resource AWS instance, and let's say here you have the respective AMI number, which is basically your Amazon Linux instances. And you have to also make sure that you select the correct AMI ID, okay, and then the instance type and what is the key name that you have. So this is kind of like how you give the provider configuration. So which is kind of very, very much important. And the file name, you can create it something like as main.tf. So let me give you one more scenario. Let's say there is a tech startup that provides cloud software solution and wants to automate the provisioning of virtual machines for different customer environments. So how Terraform can help in this scenario? The Terraform uses AWS provider to define EC2 instances, and the customer, they create isolated environment with specific virtual machine sizes, security groups, and storage configuration. And Terraform automatically provisions these environments, ensuring scalability and reducing manual configuration error. And this process reduces the deployment time and helps maintain a standardized setup. Now guys, let us try to understand a bit about input variables. Input variables basically allow you to pass dynamic values into a Terraform configuration, which makes it more flexible and reusable. For example, you can pass values like region, instance type, environment like dev, staging, or production. And here the output values are used to display the important information like after Terraform has applied the configuration. This could be things like IP addresses, DNS names, or data about it. For example, guys, let me show you. So let's say we have this respective configuration. So I'll just write it down here. Let's say we have the variable. So if we create a variable something like this, then you give the keyword as region, and let's say by default the region is EU North. So you can copy this thing, paste it all over here, and after this what you can do is you can just close this up, and then you could write your respective resource. Okay, let's say the resource is AWS instance, and then you have the respective web server, and you can have the respective AMI. Let's say my AMI is this only. I'll just copy this. Okay, and you can give your instance type and just add the same thing. They can add your region, and how to access the respective region, what you can just give, you can just type var dot region. So this is how you can access the respective thing all over here by declaring your variable. So this is kind of very much important, guys. It's like the variable declaration. Now let me tell you one of the another interesting use case scenario, guys. Let's say, for example, if you have a cloud infrastructure team which basically wants to deploy and manage hundreds of virtual machines across multiple environments. So they can define region as the input variable so that they can deploy the same configurations in different regions. For example, let's say the regions can be US West 2, US East 1, EU North 1, so without changing the underlying code. Output values such as the VM's or public IP address are automatically displayed after successful deployment. And these IPs are used in other automation scripts for configuring load balancers or monitoring tools. Now guys, let us discuss a bit about state files, local versus remote state. So guys, by default, Terraform stores the state file locally on machine where the commands are run. And this is very useful for personal or small projects, but it is not recommended for teams. For example, if I talk about remote state, it is used to store Terraform state file in shared location, for example, in AWS S3 or Azure Blob Storage, which allows multiple users or CI/CD pipelines to work with the same infrastructure. So guys, this could be the respective configuration that you could write. Let's say we have the respective Terraform, and let's say the backend is S3. You could give your respective bucket. Let's say this could be my Terraform state. Then you can declare your respective key. Let's say the key could be state Terraform state. Okay. This you can write Terraform tf.state. You could give the region also all over here. And let's say the region is US West, something like that. And then you can close it all over here. So this is how you can manage your respective state all over here. So guys, a scenario you could imagine where you could use this thing. Let's say there is a multinational corporation with teams in different countries and it's managing its cloud infrastructure across multiple regions. The company uses remote state with S3 as a backend to store the Terraform state file. And this is ensuring that all the team members, regardless of the location, are working with the same up-to-date state. Using remote state also allows Terraform to log the state during deployments, preventing race conditions, where two users might try to modify the same resource simultaneously. And this is very much critical for ensuring consistency and avoiding conflicts in the large-scale environment. So guys, let us move to the next step. Now, here we are going to understand the Terraform workflow. So I would suggest you first create a folder, name it as Terraform EC2, and inside this, create one file named main.tf. And you can also create one file terraform.tf.state, but this is actually not required. Now, if you click on the main.tf file, so you can see I have given my respective configuration all over here. So in order to know the given thing, I would suggest you to have AWS CLI installed on your system. Now, I have already told you how to install it. Just go to the official website of AWS and type AWS CLI download. Now guys, what you need to do in the next step is you need to sign in. So just click on sign in using your root user email. So this is AWS, and just give your respective username, and you can do it all over here. Just give your respective password and save it, and after that you will be prompted an MFA code. Now guys, what I would like to do is create an instance. So if you haven't created any instance, you can just click all over here and create a new instance. So you can see I've already created an instance Terraform demo, which I'll be using. And you can see its instance ID, the instance stays, the instance type is t3.small, and you can see the availability zone is EU North, and this is my public IP4 DNS ID. This is the public IPv4 ID, and I have not added any elastic IPs or IPv6 configuration. Monitoring is disabled, and the platform that we are using is Amazon Linux. Now, if you want to launch a new instance, just click all over here and you can create your instance. Now, I'll just click all over here. This is my instance ID, and you can see there are a lot of important information also written. So I have not added any IAM rule all over here. And you can see the manage is false. So it's a very basic demo wise. I have not added any security groups in this. So this is respective thing. Now click on the connect. And you can see connect using the public IP. Just click on connect, and you can see an instance of the respective, you can say, EC2 instance of the Terraform will be open. Now, this is my AMI ID, and you can get your respective AMI ID also all from here. So that's a pretty interesting thing. And that's AMI ID I have added all over here. So you can also get your AMI ID all over here. As you can see, this is your AMI name. So that's pretty interesting. So you can copy that AMI ID, okay, and you can paste it in your configuration. Now, this is my main.tf file which I have created all over here. Now, in this, I have given, let's say, provider is AWS, region I have put all over here, AMI ID I have copied from there. I know my instance type, this is t3.small, and I have also created a key along with my instance name. So you can easily create your keys also, guys. Just go all over here to your instance state, okay? And if you go to your respective instance all over here, so you can create your key and value pair. So guys, you can see I have created my key all over here. Similarly, you can also create your respective key. When you create your instance, so there will be an option to create your key. Now, you can see my key name is Terraform, okay? And please make sure to keep your keys safe. Use a particular name. This helps us to actually secure your respective private key which you are going to get after creating this. Now, I have also added my respective key. So what I'm going to do, guys, I'm going to open this folder in the terminal. So let's go back and let's just open in the terminal. Now you can see I have opened the respective thing. So guys, by typing this respective command, you can see my Terraform has been initialized. And it has initialized the Terraform working directory. Now, it is going to download the necessary provider plugins if you have added, and you can configure your respective backend. Now, if you type something called Terraform plan, so what you can do with this respective command, so since I have not added any changes, so it is going to generate an execution plan detailing what Terraform will create, modify, or destroy when applied. Now, if you applied any changes, guys, you can just apply Terraform apply command. So just type Terraform apply and just click all over here, and you can see there were no changes, so that's why it says Terraform has compared your real infrastructure, and it has found against your configuration, found no differences, so no changes are needed. Now, it is also going to destroy the resources defined in the configuration, which could typically be used to tear down a temporary environment. For example, guys, if you try to do Terraform init, okay, so with the help of that, you can actually start initialize the respective thing. If you try to do Terraform plan, it is going to give you the execution policy, and with apply, you can compare your real infrastructure against your configuration, see everything is correct or not. And with destroy, you can actually kill the respective Terraform. So if you type do this, so all the respective resources will be deleted. Now, let me give you one good scenario, guys. Let's say a DevOps team is working on certain project, and their main responsibility is for provisioning and managing cloud infrastructure for CI/CD pipeline. And it is building and testing a software in various environments like dev, staging, and production. So if you type Terraform in it, it is going to initialize the environment, downloads the necessary provider plugins, and then the Terraform plan command which you are using, it could be used to review the changes before they are applied, ensuring that the team knows exactly what will be provisioned or changed. And the Terraform apply is basically used to provision the resources, for example, like EC2 instances, load balancers, databases. And automatically it is going to minimize manual intervention and reduce human error. Now, once a pipeline is finished, Terraform destroy will be used to wear down any temporary infrastructure which is used for testing, ensuring that resources are only running when necessary and saving on cost. So these were some of the core Terraform concepts. Now, let us move ahead to the next part. Now, in this part, we are going to explore how to scale our Terraform infrastructure using modules. Basically, with the help of modules, you can organize your Terraform code, which makes it kind of reusable and manageable, especially when working with larger team-based or enterprise level projects. Now, if I talk about what exactly a Terraform module, so in Terraform, module is like a container for multiple resources that are used together. And a module can consist of single resource or collection of resources that are logically grouped together to perform a specific task. Modules can also help organize code and allow you to reuse it across different configurations. Now, there are some very important concepts, guys. For example, let's say if we talk about, let's say, encapsulation. So modules also allow you to encapsulate a group of resources into a single entity, which can be reused and shared. Now, once it is defined, a module can be reused in different parts of the infrastructure or even in projects. Modules can abstract the complexity of the underlying resources, allowing you to use them without worrying about their internals. Now, guys, let us discuss a very important concept of why you want to create a reusable EC2 module. Now, let's say you have created one EC2 module and you want to reuse it. Now, if you do this, it will be very much helpful when you need to create similar resources like EC2 instances. So you have seen that I have created a EC2 instances, and let's say if you want to recreate that, let's say in multiple places or across different environments, so instead of just writing the same code over and over, you define the module once and then you can call it whenever needed. And it saves time, reduces the duplication. Now, if I just type what are the steps to create. So guys, if you want to create a reusable, let's say EC2 module, so first of all, you need to define the module. Create a new directory like EC2 module, like I have created in the folder. And then you need to add the input variables, something like this. And where you have to allow the module to accept dynamic values like the instance type, AMI ID, and any other parameters that might change. Now, what you need to do is you need to create the outputs also, because output is very useful information like instance ID or public IP addresses that could be used. Now, guys, let us come to the very important part, that is Terraform state. So Terraform state file is a crucial part of infrastructure as a code workflow. It keeps a track of resources that Terraform manages, storing metadata about these resources such as their IDs, attributes, and dependencies. And the state file is what allows Terraform to perform operations like plan, apply, and destroy. It also provides with necessary context about what is deployed in your infrastructure. Now, how Terraform uses the state, guys, let me tell you about this. So let's say when you run Terraform apply, so Terraform compares the current state of the infrastructure, which is stored in the state file, with the desired state, which is kind of you have defined in a .tf files. Now, if there is any discrepancy, Terraform will generate a plan to update the infrastructure. Now, you'll also see something called as dependency graph, and the state file also maintains this graph of resources, which enables Terraform to understand the order in which resources should be created or destroyed. For example, Terraform understands that a security group must be created before launching an EC2 instance, and that depends upon the security group. And if I talk about performance and optimization, state also helps to optimize Terraform's performance by caching up the resource data. For example, the Terraform will avoid querying cloud APIs repeatedly for information about resources that haven't changed. Let me give you one scenario. Let's say there is a company which needs to manage infrastructure across multiple regions, and they have this environment, dev, staging, and production. So the state file is going to track the resources created in each of these environments, such as EC2 instances, S3 buckets, and security group. Now, when a change is made to the type of the infrastructure, so Terraform is going to compare the desired state with the current state, and it is going to ensure that the necessary updates are made. And you also get, if you are trying to manually edit the state file, that becomes kind of risky, and generally it is discouraged because it can lead up to a lot of discrepancy in your infrastructure, and Terraform may no longer be accurately be able to track resources, and which can lead to a lot of problems, because when you need to create, destroy, or modify, it will all go incorrect. Now let's also talk about this, where we can easily say that, let's say we have a state file that contains valuable metadata such as resource IDs, outputs, and if you're trying to manually modify the state file, it can cause Terraform to actually lose track of this information. Suppose a user manually removes a resource from the state file. Now, when a Terraform is running again, it will recognize that resource still exists in the infrastructure and may attempt to recreate it, leading to resource duplication or worse, the data loss if the resource has been deleted. Now, what is the best practice for this kind of scenario? So always avoid editing state file manually. Now, if you need to remove resources from the state, use Terraform state rm command. So this is a Terraform remove command. So you can see all over here, okay, in the respective documentation, you can see you can give the respective Terraform state rm command. So this is kind of very much important for us to try to actually use it. So you can see Terraform state rm packet device worker. This is the best way to actually figure it out. Now, if you're switching to a remote backend, let's say from cloud or S3, and you are going to DynamoDB. So first, let us understand backend. What is backend in Terraform? So backend in Terraform determines where a state file is stored and how it is managed. So by default, Terraform uses local state for storing the state file on the local machine. However, for collaborative environments, team-based projects or remote backends are recommended to ensure consistency, security, and collaboration. Now, there are a lot of benefits of remote backends. First of all, the state storage. So remote backends store the state file in a shared location, making it accessible to all the users regardless of their local machine. You have the security also. State files often contain sensitive information, for example, like resource IDs, secret keys, etc. And storing state remotely allows you to manage access permission, encrypt the state file for better security. And you can also do the collaboration. So multiple team members can work on same infrastructure without worrying about conflict state files. And remote backends also provide a centralized way to access and update the state. And if we talk about it, the Terraform Cloud HashiCorp has hosted service for managing Terraform runs, state, and other aspect for where you can secure and centralize the management of files along with features like access control, versioning, and history. Now, guys, if you want to configure a Terraform Cloud backend, so you can just give something like this. Let's say here you can give your output name, let's say the current working space, then you declare your respective variable, let's say the type is string by default, and this is a remote code execution, value is remote, run environment, and modulo if this is a conditional. So if var.hcp terraform run id is not equal to this, then go yes, otherwise no, this is a local. So this is kind of pretty much interesting. This is a basic configuration that you are having. So let's say Terraform backend remote, host name, let's say it is Terraform.io, and let's say the organization is a company. You might have the workspaces, let's say name my app production, and you can use multiple workspaces like Terraform. There will be backend remote, host name, organization, and then you have the respective workspace. So for prefix, you can use it like my app. And you can use the CLI input also all over here. Let's say this is main.tf file. So you have this required version. Let's say this is a backend remote. And this is your respective configuration file all over here. So you can initialize your respective configuration for the backend like Terraform init, backend config equals to config, remote.tf.backend. And similarly, you can give the data source configuration also all over here. So let's say if the data is Terraform remote state, let's say it's given food, the backend is given remote, then you create a configuration, organization, your company name, and then you can create your workspace name. Now you can see all over here, these are the configuration names supported, like your host name, so which is like your remote backend host name, your organization, your token, which is used to authenticate the remote backend. Then you have the workspaces, which is kind of a block specifying which remote workspaces to use. You have name, you have prefix all over here, which is like one of the names used for remote workspaces. Now guys, let us try to understand a bit about state locking and collaboration. So state locking is a mechanism which is used to prevent multiple users or process them from modifying the state file simultaneously. Let's say when one user or processes apply changes to the infrastructure, the state file is locked to ensure that there are no other users who can make conflicting changes. Now, once the process is finished, the lock is released. Now, why is this state locking important? So, in a collaborative environment without state locking, it's possible for multiple users to attempt to modify the same state file at the same time, which can lead to corruption or conflicts in the infrastructure. So, state locking ensures that Terraform operations are serialized, making Terraform management prediction safe. And let's say when you are using a remote backend like S3 or DynamoDB or Terraform Cloud, so state locking is automatically handled. And DynamoDB is commonly used to log the state file when you are using an S3 backend, so preventing multiple users from making the changes. Let me give you one good scenario. Let's say there are two team members who are working on the same Terraform project. One runs Terraform apply to provision the resources while other tries to run it at the same time. Now, with the state locking enabled via DynamoDB, the second user will receive a message indicating that the state is locked and they must wait for the first user to finish before proceeding. Now in Terraform Cloud also, state locking is handled automatically when multiple users are running Terraform in the same workspace to ensure no conflicting updates are made simultaneously. So guys, this was a bit about state locking. Now, if I talk about troubleshooting and what are the best practices, the first thing that comes to my mind is writing clean, dry, and modular code. Now, what is dry? So dry stands for don't repeat yourself. It's a software development principle that encourages the reduction of code duplication. So by applying dry principle to Terraform, you can avoid writing the same code multiple times, making your infrastructure code much more efficient and maintainable, and also less prone to errors. So how to write dry code in Terraform? So modules can help encapsulate the resource definitions into reusable units of code. So just instead of defining the same resource like an EC2 instance or S3 bucket in different places, define it in one module and reuse it throughout your configurations. So now if I talk about something next, that is variables and outputs. So instead of hard coding values to your resources, use variables for dynamic inputs and output for values that needs to be shared across modules or with other systems. You need to avoid duplication of the resource. For similar resource such as multiple EC2 instances or S3 bucket, create a generic module and pass the parameters like instance type or bucket name to avoid writing. So example of a dry code, you could see something like this. Let's say EC2 module slash main.tf resource AWS instance. Then there is a web server. Okay. And in the web server, you can see they have the EMI. You can take it as from the variable EMI ID, instance type, and the respective region, or are stored in the respective variables. And then you create another module and you can use your variable EMI ID, variable instance type, and variable region. So in this way, you can reuse it across your given application. Now, if I talk about calling the EC2 module, so in your main configuration like main.tf, you can call the module with different parameters. For example, if you see module web server, source, EMI ID, instance type, and region. So please, you can follow these kind of approach also. Now, using a consistent naming convention is very, very much important, which helps you to track that whether Terraform code is organized, readable or not. It also makes it easier for teams to collaborate, troubleshoot, and scale the infrastructure. Now, you have to name your resources in a way that clearly indicates their function. For example, instead of naming an EC2 instance, you can name it to web server dev. You could give it this kind of nomenclature. And you have to also use environment prefixes. Do include that, guys, like dev, staging, or prod. And use consistent naming schemes for the sakeness. And let's say this is web server prod or something like this. Now you can see here I have written resource AWS S3 web server logs prod. So this kind of nomenclature is very much appreciated. And then you give your given bucket name and ACL all over here. So guys, these were some of the troubleshooting things. So guys, that was all for today's video. I hope so you would have enjoyed our today's video on Terraform. And also guys, do not forget to hit the subscribe button and click the notification bell icon so that you don't miss out any update from our. Thank you guys for watching this video.